In this video, we're going to look at how to work with mass and molecules in a balanced equation. So we're going to require, firstly, a balanced equation, and secondly, we're going to need something called the boxed expression, which contains three pieces of information. We've got x grams, we've got 1 mole, and we've got Avogadro's number of molecules or atoms, and then x is going to stand for our molar mass. So let's take a look at a question here. So we've got the synthesis of ammonia, and the question is asking how many molecules of N2 are going to be required to react completely with our 10 grams of H2. So to start this question off, we're going to write down what we're trying to find and set it equal to what we know. So what are we trying to find here? We're trying to find the molecules of N2. And what do we know? We know we have 10 grams of H2. Because we have two different substances here, we're going to need 3 steps to solve this. And we're going to need the boxed expression. So step 1 is going to come from the boxed expression. It's going to allow us to convert moles and grams. So that's what we want. We want x grams and we want 1 mole. So the x grams, dealing with H2, is going to be the molar mass of H2, which is a little more than 2. We're going to want to put that on the bottom. Why the bottom? So that our grams of H2 can cancel with each other. And so if we have 2.016 grams of H2, that means we have 1 mole of H2. Step 2 is a mole ratio, comes from a balanced expression or balanced equation. We've got 3 in front of the H2, and we've currently got nothing in front of the N2, but really technically we've got a 1 here. So we're going to need to put the words 1 mole of N2 and 3 moles of H2 somewhere in step 2 here. So we'll start with the H2. We currently have 1 on the top here that isn't canceled out. So to get that one to be canceled out, we'll put the 3 moles of H2 on the bottom, and those will cancel out. To finish up our mole expression, we'll put the 1 mole of N2 up top. Now, the last step here, step 3, again, we're going back to the box expression. And what we're going to need in this step is we're going to need moles, 1 mole, and we're going to need Avogadro's number because that's what this question is asking us. It's asking us something about molecules. So for starters, we'll get the moles of N2 to cancel. We'll put 1 on the bottom, so it'll cancel with that previous 1 on the top. And then we're going to have Avogadro's number up top here. So now it's time to grab your calculator. You're going to want to put 10 times 1 times 1 times Avogadro's number. Hit the equal sign. Divide by 2.016. Hit the equal sign and then divide by 3, and if you do that, you should get about 9.95 times 10 to the 23 molecules of N2. So that's how many molecules are going to need to be required or are required to react completely with 10 grams of H2.